Let's now turn our attention to organic nitrogen sources. And these include many different types of compounds or amendments. And those would include, like listed here, manures, compost, biosolids, fish meal, bone meal, blood meal, etc. And these types of products contain nitrogen in both inorganic as well as organic forms. And the ratio of organic to inorganic is variable. And you'll see that on one of the subsequent slides. When we look at the inorganic forms of nitrogen that are present in organic amendments, the inorganic form of nitrogen that dominates is ammonium. And when you think of ammonium, at this point in this class, you should think of loss pathways, and the very first loss pathway is volatilization. The organic forms that are present in organic amendments that contain nitrogen are variable, and they range from amino acids to proteins to urea to complex organic moieties, etc. So there's actually a broad spectrum. And at this point in time, based on what you've learned so far in this class and other classes, that organic nitrogen has to be mineralized before it can become plant available. And so when organic nitrogen undergoes mineralization, there's still a chance of volatilization losses, correct? Correct. And did I miss something? Okay, so when we look at the typical ratio of ammonium to organic nitrogen in various types of manures, for example, this is often what you see. So we're looking at dairy, beef, swine, and turkey manure. The amount of ammonium present as a function of total manure nitrogen, and the amount of organic nitrogen present as a function of total manure nitrogen. And oftentimes the amount of nitrate nitrogen is negligible. In fact, more often than not, I don't think I've ever seen a situation where inorganic nitrate nitrogen is at a great enough concentration in any of these materials to be significant. So these numbers are not set in stone. There is no fertilizer guarantee for an organic amendment, unlike inorganic fertilizers that we purchase from Home Depot or Lowe's or a co-op. And so these numbers are variable. And how do you actually know how much of ammonium nitrogen is present or total organic nitrogen is present or total nitrogen is present? You need to get a test performed. And most soil testing facilities will do this for you. You can send in a manure or biosolids and we'll test it for you. You should know by now that this form of nitrogen, ammonium nitrogen, is completely available for plant uptake. And because it's in the ammonium form, it has the potential for volatilization. You also should know that organic nitrogen is slowly degraded or mineralized over time. And you already know this from previous videos and lectures, that the mineralization rate is dependent on a number of different factors, right? It's dependent on moisture conditions. It's dependent on temperature. And these two play a role in terms of release of nitrogen to the inorganic form over time, which oftentimes makes manures a little more attractive in terms of releasing or slowly releasing nitrogen over, say, a growing season or several growing seasons. There's one other thing I want to point out on this slide that we haven't talked about yet, and we likely will in the subsequent unit 5, I think unit 5C. And if we don't talk about this, we should talk about this now. So up to this point, we've talked about ammonium. Oftentimes, when people talk about ammonium, they might not just say ammonium. They may say ammonium nitrogen, or instead of saying nitrate, they may say nitrate nitrogen. And we do this to express the form of nitrogen that we are interested in. All right, so this ammonium nitrogen is simply nitrogen but in the ammonium form. I don't know if that makes sense to you or not. If we want to know nitrogen in the nitrate form, we say nitrate nitrogen. We don't say nitrate. All right, so the focus is on nitrogen, but it just so happens to be, in this case, in the ammonium form. If we're focusing on nitrogen and it just so happens to be in the nitrate form, we say nitrate nitrogen. I'll leave it at that, just FYI. So going back to the previous slide and talking about the fact that organic nitrogen is relatively slow to mineralize over time, there are different mineralization rates that you will find, and mineralization rates are never set in stone because they change based on the factors that affect mineralization. So here's some estimates, right? And these are just estimates. Liquid manure or solid manure or compost, and the percent of nitrogen that would be mineralized from each one of these three sources in year 1, 2, or 3. So if you look at these numbers, they roughly are cut in half from one year to the next to the next. So if you really want to know what the mineralization rate is of a material, you need to apply it and then follow or track the amount of nitrogen released over time. I can tell you that many scientists, including myself, have done this in our careers, and we can tell you that the amount of mineralization varies, and it can vary. If you were using, let's say, solid manure, it could vary from maybe 20% to 35%. And so the number is not set in stone. So this is what we're going to do for this class. And I like this rule if you ever have to use this outside of the classroom. A simplified rule of thumb is 30% in the first year. 30% of the manure total nitrogen available is available in the first year. And then half of the remaining nitrogen is available in subsequent years. This is a good rule of thumb. Now, let me tell you one other caveat to all of this. So when you apply a manure based on a rough guesstimate of 30% mineralization rate the first year, you can estimate how much nitrogen is going to be released in that given year. And if you know how much nitrogen is going to be released in a given year, you can apply a certain amount in maybe tons per acre to equal the demands of a certain crop that you're growing. All right. And what you can do is you can check or soil sample the subsequent year to see how much nitrogen is remaining and perform back of the envelope calculation to see if that amount of nitrogen that's remaining is enough for the subsequent crop. And there's a series of checks and balances here with manure or organic amendment applications that I think is important to stay on top of if you're a producer using manure. That way you're always on top of how much nitrogen is present and you don't have to over apply or you don't under apply nitrogen as well. So there are plenty of organic fertilizers, and some of these you can buy, some of them, well, you can buy all of them. There is no guarantee, right? There is no fertilizer guarantee for any of these products. So the products range from all over the place. I'm not going to expect you to memorize any of this, but if you look at we'll just call it the grade or the amount of nitrogen present, and it ranges all over the place as well. And so having a test performed on your material that you're going to utilize over time is a really good idea. So you understand the amount of nitrogen that's present, and you can use the rough rule of thumb of 30% nitrogen release or mineralize in the very first year. Now you can see that some of these are fast and some of these are slow, and you could likely look up via Google what is the mineralization rate of nitrogen from blood meal, for example, versus manure or compost, etc., and get a better rule of thumb than 30%. For this class, let's just keep it 30% and keep it relatively simple.